Hello, good morning, everybody. Maybe good afternoon, good evening. I'll still keep saying it, but I think this is more of a morning event here today. Looking forward to having you all join the Neo4j Fundamentals virtual workshop together with Martin O'Hanlon. Hello, Martin. How are you doing today?
Hi, Alex. I'm very well, thank you. It's great fun to be here, and it's a beautiful sunny day here in the UK.
Yeah.
So that's all the
Well,
better.
it's that's good.
Yeah.
That's very good. I see people joining us from all over, from Sweden to South Africa, Johannesburg. So I think that is basically the longest distance we can get. I think between at least being in the same time zone. So that's great. Thank you for joining. Somebody from Munich, somebody from France as well. So great to see you all. Thank you for joining. Hope you have a good time today as well, and you will get good, something good out of the workshop that Martin will be presenting in a bit. Before, I'd like to make a few housekeeping items so that we all on the same page. So we record this session, so you don't have to, you know, I wanted to say pay attention, but obviously you have to pay attention all the time. But if you miss something or something is going by a little bit quick, or if you have to drop off early, then you can always come back to the video recording, which we will send you later this week, probably by tomorrow. We will also share the slides that Martin will use with you in a follow-up email, so you will have that. If you have any questions during this presentation, during this workshop today, and if you have, or anything is unclear, we will have some breakpoints where we can look at these questions and read them out live. So please use the Q&A panel you should see on your right hand of the video stream. If you just wanted to say that you like the presentation or want to chat about things, use the chat. It's fine. If you post a question by accident in the chat panel, I'm moving it over to the Q&A. So don't worry if you see a question disappear. It's just for organizational sakes. It's easier for me to see what's a question, what is just chat. So that's why I'm moving them away, but I'm not deleting your question. So yeah, I think with that we are ready to kick it off. And I wish you all good session. Have fun, and yeah, over to you, Martin.
Thank you. Great. So thank you all, and welcome to this session on Neo4j Fundamentals. My name is Martin, as Alex introduced. I work for Neo4j as a technical curriculum developer. My job is to create educational materials. So let's just have a quick look at what we are going to do today. Just as Alex has done some housekeeping, I'm going to do a little bit as well. You may see me looking from side to side. That's because I have multiple screens. One's got questions on, one's got stream information on it. But yeah, so if you see me do that, that's why I'm sort of looking from side to side. But yeah, in terms of what we're going to do today, so we're going to spend some time looking at concepts, so graph theory, fundamentals of Neo4j. We're going to look at data modeling. We're going to spend some time exploring data in a graph. We're going to look at Cypher. Cypher is the query language for Neo4j, and we'll look at how we can interact with the data in our graph, and we'll also do some data importing. So the first thing to say is, this session is an abridged version, a shortened version of 4 courses on Neo4j's Graph Academy online learning platform. So if you want to dive into more detail on any of these topics, you can do that by going to graphacademy.neo4j.com, where you'll find lots and lots of free courses and free certification programs as well. So today will be an interactive session, right? And I want you to follow along, right? If you would like to, and you'll get most out of it if you do. In order to do that, you're going to need 2 things. First of all, you're going to need to download this zip file, which contains the data that we are going to use throughout the session. And the next thing I would like you to do is sign up for Neo4j Aura. Aura is Neo4j's cloud platform. And I'm going to go through the process of signing up as well, so you can follow along with me. And we're going to use Neo4j's data importer to create a database containing movies and people, and we will run some exploratory queries using Cypher. And sort of by the end, you should be comfortable loading your own data, running Cypher, and kind of using Neo4j Aura to gain access to your own data. Okay, so if you haven't done so already, please go ahead and download the this zip file, number one, and then I'm going to go through the process of registering for Neo4j Aura. So another small piece of housekeeping is, so I need to remember to switch tabs, and it's something that I quite often forget. So when you visit that link, you're going to end up at Neo4j Aura. If you have an account or you've got a Google login, use one of those options. I'm actually going to go through the process of signing up for an account, just to kind of go through the whole process. So the date today is the 10th. So go through a process. I'm going to use my super secure password. Let me just find that. So here is pop in my super secure password, and I'm going to go and sign up. It's going to ask me to verify my email, so I'm just going to go and do that as well. And you should get a link asking you to verify your email address, which I'm just going to do. And hopefully, if I refresh this page, I should be welcomed into Neo4j Aura, and I'm going to finish off the sign up process. One of the things I quite like about the sign up process for Neo4j Aura is that it creates this little graph as I am going through the process. What we can see here is we can see two nodes and a relationship between those two nodes. Martin O'Hanlon works at Neo4j. I'm working on a personal project. I'm a software developer. I'm interested in generative AI and knowledge graph. Great. And I've got to the point where I'm just going to create a free instance. So with Neo4j Aura, everybody can have a free instance. It's yours forever. And all you have to do is create the free instance button. So it's going to take a little while to create our instance. So I'm going to carry on with the presentation. However, before I do, it is very important that you download your admin credentials for this instance. They are only shown once. So let's just make sure that we do that. I'm also going to be super cautious and copy them to the clipboard as well. All right, so brilliant. So it's going to take a little while to create the instance, but we'll carry on and learn a little bit more about Neo4j. Okay. So we've been through that process of creating our free instance. So, first off, what we're talking about here is we are talking about graphs, right? And I don't mean these sorts of graphs. I've learned to call these charts in the time that I've been working for Neo4j. What I'm talking about is these sorts of graphs. So graph theory. So let's spend a little bit of time talking about, what do I mean by graphs and graph theory and the elements within a graph. So graphs essentially consist of nodes. And these nodes represent things or entities. So in this case, it's a movie, but it could be a car, a location, something physical, something abstract. It doesn't matter. It represents a single thing. And we can identify these nodes with labels. So we can categorize nodes as, groups of labels. So in this case, Toy Story is a movie, but also nodes can have more than one label. So Toy Story is a movie. It's also an animated. Nodes can have properties. And this is how we store data. So nodes have a type, label, and they also have properties. Title, release, plot, URL, anything else that you can think of that is important to store against your node. And we store properties as key value pairs. So, a key, title, value, Toy Story. Now, the power of graphs comes in the relationships between the data. So here I have another node representing the actor. So it's got an actor label, the actor Tom Hanks. And there is a relationship between Tom Hanks and the movie Toy Story, which is acted in. So relationships have a type. Tom Hanks, the actor, acted in the movie Toy Story. All relationships within Neo4j have a direction. So Tom Hanks acted in Toy Story. Obviously, Toy Story didn't act in Tom Hanks. Relationships, can also store properties. And this is a differentiator when we're thinking, particularly if you're used to relational databases where relationships are abstract things between primary and foreign keys. Relationships within Neo4j can hold properties. In this case, it's the role that Tom Hanks acted in the movie Toy Story. And again, they are key value pairs. And it's really worth noting that relationships are real things in a graph. And that being a kind of key difference. So let's just recap that. Let's just recap that. We have the actor Tom Hanks is a node. The movie Toy Story is a node. Relationships connect two nodes together. Relationships always have a type, and both nodes and relationships can store properties. Okay, so let's talk about why. Why are graphs useful? When and I think the important thing to kind of recognize when using a graph is that the relationships are as important as the data they connect, and that is a key differentiator when looking at a graph and understanding why they are useful. So if you need to understand the relationships between entities, for example, how people are connected, or you have a problem that involves self-referencing the same type of type of entity. So, for example, a hierarchy of employees within a company, where you might have cyclic references within a relational database, or just simply you need to explore relationships where you don't know, for example, the depth. So I'm looking for relationships within. I'm looking through relationships within a hierarchy, but I don't know how far down I need to go. So things like a bill of materials, so the things that make the parts that make up a finished product. So the sort of one of the things that I think is sort of important is that if you had a career like mine, I was sort of conditioned to think of data in terms of tables, like rows and columns, whether that's like a relational database or a spreadsheet or just a CSV file. Tabular data is ubiquitous, it's tried and tested, and it works really well for a lot of use cases. And typically we represent data like this. So we have tables that store data. So in this case, I've got a relationship diagram that talks about movies and people and users, and then we have tables just to manage relationships. So in this case, the linking tables or the many-to-many tables that go between our data tables. And there is a problem here, which is the big O notation or the big ON notation, the big ON problem. Which is, in order to be able to query across relationships, we need to use foreign keys, primary keys and foreign keys, and they're backed by an index. And as the size of the table increases, so does the size of the index, right? And as the number of relationships grows, our queries get slower because our index gets larger. And the more tables you join, your query will become exponentially slower. That is not the same within a graph. And if you find yourself asking these sorts of questions, you've probably got a graph problem, which is, do you struggle with complex data schemas? Do you struggle with poorly performing database queries, particularly over relationships? Do you storing like networks of data? And do you need to analyze the connections between the data rather than just the data itself? And these are graph problems, and they are probably better supported with a graph than a table, because graphs, graph database are designed to efficiently store and query complex relationships of data. And that goes from like the underlying data storage, right up to the query language itself. That's what graphs are good at, understanding complex networks and relationships within data. Okay, I just need to take a quick drink. Okay, so let's go off and import some data. If you have just joined, here is a couple of links for you. So what we're going to do is we are going to import some data, some movie data, a similar data set to that schema we were just exploring. We're going to import that into our Neo4j Aura instance, the one that I just created. So if you've just joined, here's a couple of links for you. One is the data itself, and one is a link to go and register for Neo4j Aura, where you can create a free instance. Okay, but let's go back to Aura. So we are now back in Aura. My free instance has been created and is running. So what now at the moment, this is an empty database. It's got no data in it, so we need to put some in, right? And the file that you downloaded contains not only some data, but also a data model. And that's the first thing we are going to do. So we are going to use the Neo4j data importer, which is under this import tab. And if I click on there, we can connect to existing data sources, whether that's a relational database, your relational database, or some flat files, and import that data into Neo4j. Now, in this case, my data source is some locally stored CSV files. That's what's in that zip file that you just downloaded. So that's going to be my data source, and it's going to create a new model for me. So what I'm going to do at the moment is to kind of get everything started quickly. I have defined the model for us, and then later on in this stream we're going to modify it. But for the moment, if we go to the menu in the top right hand corner, which I think is just off the screen, maybe. Yep, there. Thank you, Alex. If we click there, we can say open model with data. And it's going to ask us, there's a pop-up appears, and it's going to ask us to select a zip file. So I'm just going to select that movie fundamental zip file that we just downloaded. And once I do that, it's going to import the CSV data that's in that zip file and this data model. So these are the files that are inside the zip file. These are the files that we are going to be using, or the data that we're going to be using in the stream. And here is the data model that we are going to create. It's got two nodes. It's got person nodes, and it's got movie nodes. So again, it looks very similar to that model we were just exploring. And it's got two relationships: an acted in relationship and a directed relationship. And we'll explore how to import data, because we're going to expand on this model a little bit later. For the moment, we can just run the import and let's get some data into our database. I need to connect to my instance, which when I connect, it's going to ask me for my database credentials. So when we created our instance, that was why I said download your credentials, and you will find in that file that you downloaded that had your credentials, you will find a database user and a password. So here is my password. And I'll be able to connect to my free instance. And so straight off, so I connected to my free instance, and it has run the import. That happened very quickly. I didn't have time to explain what was going on, but I connected to my instance, and it used the data within that CSV and the model that was defined to create nodes with person labels, nodes with movie labels, and these two relationships. And once we've done that, we can go off to explore the results. So this is a tool that we call Bloom. It's an exploration tool, but if we sort of zoom in, we can see that we have data within our graph. The colors denote the labels of the nodes. So in this case, there is a node, Irene Jacob, that has a person label, and we can see these properties associated with that node. So there is a bio, a little bit about Irene, when they were born, where, some IDs, and some URLs. We can also see that Irene has a relationship to another node, which is a node with the label of movie and the title Othello. So we can denote from this that Irene Jacob, the person, acted in the movie Othello. And again, if we double click on that node, we can see the properties associated to that node as well. Okay, right. And, you know, zooming in and out, we can sort of explore this graph, and we'll see different nodes and different relationships. Okay, right. Let's pop back to our presentation. So we're going to spend a little bit of time looking at Cypher. So Cypher is a query language, and Cypher is the predominant way that we will interact with our Neo4j database. All right, so let's do some definitions. So sorry, excuse me. Let me just find. I've lost my place. Okay, here we go. Right. So Cypher is a declarative query language, right? So declarative means that you express the logical what you want to happen without describing how it happens. So, you know, as an example, SQL is a declarative query language, right? But it allows you to identify patterns, right? So identify patterns in your data using this ASCII style art syntax of brackets. So brackets, so nodes are described using round brackets. You can denote labels within your brackets. So in this case, I'm looking for person nodes, or I'm looking for movie nodes. We use dashes and arrows to denote relationships and relationship direction. And we describe the relationships that we are looking for within square brackets. So we can also include variables. So let's just kind of recap this. This pattern here says find nodes that have a person label that have an acted in relationship to a node with a movie label. The P, the R, and the N are how we denote variables, and we can use those variables within our queries. Okay, so let's just have a quick look at how we use those patterns, and we use Cypher to read data. So when we are reading data from a graph, we would typically use match. So we're going to find a pattern in the database. This is the pattern we're looking for, and we're going to use match to do that. We can filter based on node properties. So in this case, you know, filter it where there is a title property on the movie node called Toy Story. And then we can choose what we want to return, whether that's properties, So in this case, the person's name, and then the relation, and then the property of the relationship, or we could return nodes themselves. And if you're familiar with SQL, the match and the pattern, I suppose the greatest similarity is the sort of from join. So you're specifying the data that you are looking for. Where is essentially where, and return is the equivalent of select, what you're looking to get out. Okay, so let's just have a quick demo, and we will look at using Cypher to read some data. I just need to move that over there, and I need to switch back to Aura to share this tab. What we're going to do now is we're going to use, if I can find my mouse, here it is. We're going to use this. We're going to use the query tool. So the query tool allows us to interact directly with the database and to execute queries and get results back. I'm going to make this a little bit bigger. Hopefully that looks a little bit bigger and is a little bit more readable. So let's use that idea of using match to find data and using this idea of patterns. So if I'm going to find data, I need to express a pattern of what I'm looking for. And patterns can be as simple as single nodes. So match P, match all of the nodes that have a person label, give them the variable P, and then return P. So return all of the nodes that have a person label. And if I run that, we're going to see a graph returned of lots and lots and lots of nodes. And if I zoom in, we'll be able to see, there is a node that has a person label and has these properties associated with it. So that's kind of a good start. And let's, we can use the idea of using a where clause to filter data. And I'm just going to go off and try and find a single node, a single person node that has the name of Al Pacino. And what I should get back when I run that query is I get back one single node, which is a node that has a title, a name property, of Al Pacino and various other properties. Okay, so within patterns, so you can not only describe things like the label that you're looking for, but you can also say, okay, well, actually, I want to match patterns that have particular properties as well. So in this case, find me all of the nodes, round brackets or parenthesis, that have the label person, that have a property of name that is equal to Al Pacino, and that is the equivalent of the query we just ran, where we used a where clause to filter. But I can express data within my patterns as well. So we can let's expand this pattern to use some relationships as well. So I'm going to say use the acted in relationship to find other nodes that have a movie label. So this pattern says find nodes that have a person label that have a name property equal to Al Pacino that has an acted in relationship to movie nodes. And if we return, I'm just going to put a variable against that relationship as well. And if we return person nodes, the relationships, and the movies, what we get back is a graph of, let's make this full screen, a little bit easier to read. What we get back is a graph of the movies that Al Pacino has acted in. And these patterns can be, as simple as, a single node, or significantly more sophisticated, including lots and lots of different relationships. And so I could expand this again to say acted in, use the acted in relationship to find, let's call it P2, to find the person nodes who have an acted in relationship to the movies that Al Pacino has an acted in relationship to. So what I'm going to find now is a graph of the people who have acted in the relationship, who have acted in the movies that Al Pacino has acted in. And this concept of patterns is really important when navigating and understanding data within a graph. So let's just finish off this query. At the moment, I'm returning nodes and relationships, and query or the tool browser is showing me this data as a graph. However, it is just data. But I don't have to return data as a graph in terms of nodes and relationships. I can also return properties. So in this case, I'm going to return the name of one. That's going to be Al Pacino. The title property of the movie node, and the name of the people who acted in those movies. So now I get back a table of the people who acted in the movies with Al Pacino. Right. So this is how we can express patterns and relationships using Cypher, and how we can find data within a graph. Okay, so I would like you to, I just need to go back to here to have a go. So hopefully you've managed to set up an instance in Aura, and you have imported some data. I'd like you to have a go. So here are a few queries that you can try, and while you're having a go, we'll have a look and see whether we've had any questions come in.
And we had some questions, so
oh, great!
We can go over those.
Yeah.
So we have one from Pablo. Pablo wants to know how important is the direction, actor to movie or movie to actor? I think it's more like the direction of the relationship.
So I'm it's important that, well, every relationship within Neo4j has to have a direction. The direction you choose when modeling the graph is, to be honest, up to you. It doesn't matter whether the relationship in this case goes actor to movie or movie to actor. So at the moment it goes person acted in movie. I suppose you could have movie has actor person, right?
Yeah.
From a sort of Neo4j standpoint, and from a sort of like querying performance standpoint, it doesn't make any difference. But it is important that you describe your graph in a way that makes sense to you, right? But yeah, it doesn't. It's not. It doesn't matter. I think is the thing that I'm saying. Yeah.
Yeah, it is more of a modeling, data modeling question on how you see your relationships span out, and then it you design it like this, and then it's good to follow that. Great. Next question is coming from Fred. Fred wants to know what are the limits of the free Aura edition. He has a big CSV file that I'd love to import to see what he can do with Neo4j, and wants to know if it's maybe too big.
So with Aura, I'm going to look at until very recently, a free Aura instance was up to 200,000 nodes.
I think it's been increased. So we have 400,000 nodes and 600,000 relationships. So
yes.
That's what you can go with the Aura free instance. We also recently introduced something of Neo4j Pro free trial, which gives you a week of basically unlimited Neo4j. It's the professional version that has no limits. So you could basically, for a week at least, for free, try out how it works with your larger file, or you just take a chunk out of your big CSV file. If it is larger than 400,000 individual data points, then you can try that as an option.
Yes, thank you. I couldn't remember if it was 300 or 400,000,
Yeah.
but I knew it had increased.
It is.
Yeah.
Yeah.
Thank you, Alex.
Absolutely. And then one more question from Julian. Julian asks, in the last example you just showed, why is Al Pacino only shown once and not repeated as P2?
So I mean, so the simple answer is because I expressed that pattern as a single pattern. The query optimizer has returned the data that it expects from that single pattern. Because I have specified an anchor node, the anchor node being the Al Pacino node, and then using the relationships to find other nodes. So the query optimizer has done that. If I'd split that pattern into two match clauses, so matched the movies that Al Pacino is in, and then specified a second match clause, which is using those movies to find the person nodes, Al Pacino would have appeared a second time. Yeah, it's basically because I'd expressed it as a single pattern.
Okay. Yeah, you could always write your queries in either way. Sometimes these long patterns, especially when it goes very deep, could be a little bit, overwhelming, and you can
absolutely
segment them into smaller parts. But then you have to include a where clause, I think, where we go later on, to exclude the repetition of the same nodes.
Yes, absolutely.
Yeah, and then that's it for questions for now. If you have more questions, more comments, use the Q&A panel, and we'll have another Q&A slot later on.
All right, great. Okay, so hopefully you had a chance to have a look at these three queries. I'm just going to go over the last one, which is using this directed relationship, because it's something new that we didn't see before. So I'm just going to share this tab instead, and I'm going to say match the movie that has a title of Toy Story. So I'm going to match a particular movie, and then I'm going to use, there is a directed relationship between person nodes and movie nodes, which is, as you might expect, it is the person that directed that movie. So in this case, it was John Lasseter. But yeah, we can see from there's a couple of things I wanted to point out from this pattern. First of all, obviously, we can use different relationship types to denote different relationships, but also relationships within patterns don't have to go left to right. They can go the other way as well. All right, great. So let's go back here. Share this tab instead. All right, so let's have a quick look at how. So we've had a quick look at how we read data. Let's have a quick look at how we write data. So writing data in Neo4j is, in some respects, very, very similar to reading data in so much as we write patterns of data into the graph. And to do that, we use the merge clause. I'm just finding. So in this case, this Cypher would merge a node with a person label that has a name property of Tom Hanks into the graph. And we could have multiple merge clauses together. So this one's going to merge one node with a person label and then another node with a movie label. And when we want to create relationships, we express that pattern. So in this case, we create a person node, a movie node, and then we create a relationship between the person node we've just created and the movie node that we have just created. In this case, person Tom Hanks, the movie node Toy Story. Tom Hanks acted in the movie Toy Story. We can also set any properties against those against those nodes that we create. In this case, the role Woody, which is the role that Tom Hanks played in the movie Toy Story. So that is the starting point of how we write data into Neo4j. And the kind of important point to note is that we merge patterns into the graph. All right, so let's have a look. So I'm going back to Aura. I'm going to share this tab instead. I'm just going to do some tidy up, close a few tabs. So what I'm going to do is I am going to create a node for myself in this graph. So I'm going to say merge. I'm going to merge a person node, and I'm going to say where the name is equal to Martin O'Hanlon. So that's me. I can also, interesting, you can also return data from a merge as well. So I'm going to merge this pattern into the graph, and then I'm just going to return that node as well. And if I do that, there we go. I have created a new node within the graph that has a single property of Martin O'Hanlon, a single name property that is equal to Martin O'Hanlon. And again, if I wanted to use set, I could say set p.bio technical curriculum developer Neo4j. Not a great bio for a graph of movies, but again, if I run that, what we end up is we end up with, again, one node, but with two properties. Now the kind of the point I just wanted to make here is, so I have run this query twice. However, it will have only created one node within the graph. Merge, as the name suggests, merges a pattern into the graph. So it's going to check to see if this pattern exists before it creates it. There is an alternative Cypher clause called create, but most of the time it is more useful to use merge than create. So when I ran this query a second time, it didn't have to merge this pattern in because it already existed. However, it returned it and allowed me to set an additional property against that node. All right. So let's just expand on this query. So I've merged me in. I'm also going to merge in a new movie. So I'm going to create another node that has a movie label, and I'm going to set the title to be GoldenEye, a movie that I like. And again, so if I actually let's do this. So I'm going to return both of those. I need to put my round bracket at the end, and if I run that, I now get two nodes. Just make this full screen. I get a node with a movie label and the same node that we've seen before with me in it. So I'm going to say I'm going to merge into this graph a new relationship. So I'm going to say that the person node, me, directed the movie GoldenEye. So I create this, I merge this node into the graph, and it merged this node into the graph, and then I merge this relationship, give it a direction. Actually, if I give that, we can then return that as well, and we can see the result of what we have created. So now I have a person node, a movie node, and a directed relationship. And again, I could use set to set any value within the nodes that I've created. So I'm going to say I'm not sure what year GoldenEye was released. I'm going to guess at 2001. And now I have another property against my GoldenEye node. Okay, and that is essentially the basics of how you create data within a graph. You define patterns and you merge or create those patterns within the graph, and then you can set properties and and any other data that is appropriate for those nodes and relationships. Okay, so we have another opportunity for you to have a go. So I would like you to create a person node for yourself, and then give yourself a role in a movie by creating an acted-in relationship to that role, to that movie, and then you use a match query. So use the match query that we saw previously to read data to find the node that you have, the node and relationship that you have just created. And while you're doing that, we'll have a look if there's any more questions.
There are some questions. Just to I'll read them out in a bit. But GoldenEye actually released already in 1995. So
okay, thank you, Alex.
couple years off.
6 years, that's not too bad.
It's not too bad, no.
Yeah.
No. Cool. There's a question from Victoria. Victoria asks, what steps should we consider when importing a large existing database, such as something from Snowflake?
I mean, I suppose the easy answer to this question is, the same considerations you would apply when creating any other data model. Think about the use cases that you are looking to achieve. Think about the data model that you are looking to create. Start by doing some tests. So start by importing small data sets to start with, and then obviously expand over time. Some specifics to Victoria's question. So there is a Snowflake data connector for Neo4j, which will take away a lot of that hard work for you. But again, I would start with the standard good practice. What are you looking to achieve from your graph? Define your use cases, understand your data model, and then test and repeat. So try it with a small data set to test, does it fulfill your use cases, and then expand. If we're talking about things like large volumes of data, there is a question about how large, right? There are lots of different methods of importing data into Neo4j, including like raw data import, which can handle billions of rows. I probably, and I would point you to our Graph Academy platform. There is a course called Importing Data Fundamentals that goes through a lot of those questions and gives a lot of solutions to that as well.
Cool. I'll look that link up.
Thank you.
Importing, here it is. I'll share it in the chat for everybody to see, which is and Victoria, you can also check out that link. Cool. There is another question from Fred. Well, actually, it's a lot.
I've seen 3 questions.
Yeah,
from Fred.
it's three questions from Fred, but I think it's all relating around the same concept of how and what to do with bidirectional relationships.
Okay. So I mean, so let's just do fundamental first. Relationships have to have a direction. If, however, you want a bi-directional relationship, and the example I use quite often is Martin is married to Leonie. That is a bi-directional relationship. We would have two relationships to model that. Martin is married to Leonie. Leonie is married to Martin. So there would, in fact, be 2 relationships between those nodes, one going one way, one going the other. See, there's a question for Fred also about if we query with the wrong direction, the result will not be the same. Yeah, absolutely, right. If you specify a direction that says movie acted in person, you're not going to get any data back, because there is no relationship, there is no acted in relationship that goes from movie to person. And then there was the other direction used in the query. Yes, it will. Yes. I think I've covered off Fred's question there as well.
Yeah. Cool. That's all the questions we have for now.
Right. Great. Okay. All right. Well, so I've gone back one. So this was the sort of challenge, the challenge that I set. Again, I'm not going to go over. We've sort of seen how to do this. What I will just do though is just sort of say, okay, well, we can go off and match, a person node that has a name property of Martin O'Hanlon, and it will return me using a match clause. Just I suppose just going on some of Fred's questions about relationships. Relationships absolutely have to have a direction. However, if you are using Cypher and you don't specify a direction, so this
We still see your slide. Have a go.
Thank you, Alex.
Yep.
So we just wanted to show that, yeah, we can write a match clause that returns me. If and we can, while relationships absolutely have a direction, if I create a pattern that doesn't specify, so there's no arrow to specify the direction, Cypher will assume a left to right. Oh, I didn't act in any. I created a directed in, didn't I? Yeah. So there you go. Martin directed golden. Yeah. So Cypher will assume a left to right direction if you don't specify one, but every relationship has a direction. All right. Let's go back to slides. I'm going to remember to share the tab. So let's just spend a little bit of time talking about data modeling. Let me find the right bits. Okay, so the first thing to note when you're looking to create your data model is we talk about this idea of like a golden rule, and essentially what it says is a really good place to start if you're looking to model your data is noun for movie labels, verbs for relationships, nouns for movie labels. So person, purchased, product. And it's also really important to note that if you have a single relationship, so person, purchase, product, you may need to build out a network from this fact. So person, placed, order that contains product. Again, noun, verb, noun, right? It is a really good place to start. It makes your graphs easily readable and easily understandable when we use this concept. Sorry, I've my slide. Okay, here we go. Right, and when we have that golden rule of noun, verb, noun, we can also expand out from existing nodes with other nouns, and we can keep doing that, and that allows us to create a graph that is again easily readable. One of the things that we didn't talk about when we were talking about properties against nodes or relationships, and also more generally about Neo4j is that Neo4j is schemaless by default. So what I mean by schemaless is that there is no constraint. So in this example, we have two nodes that have the same label. However, they have different properties. And they can have different properties or no properties. You can have nodes with no labels. You could have nodes with multiple labels that are all different and with different properties. And all of that is fine, right? When you kind of like start up Neo4j, before you apply any constraint, virtually anything is possible. However, we know, as you know, as people that look after data custodians, is that having order to our data helps, right? So you can constrain Neo4j. So, for example, that if a node has a certain label, it has to have a certain property, or if a node has a certain label, it has to have a certain unique property. So, person, for example, must have a unique name. Now, obviously, we know that's not true. But so, person would have an ID, and that ID would have to be unique within the graph. But it is a really important point to note is that generally, when we start Neo4j, it is schemaless by design, and that has a lot of benefits as well. It means is that we can have a very, very flexible data model. Okay, so let's spend some time. What we're going to do is we're going to import some data into the graph that we have been using. We're going to import some additional data. So I am going to switch back to Aura. Actually, going to switch back to Aura, so you can see. And again, I'll just have a little tidy up. So again, I'm going to go back to the import service that we've been using. I might just have to zoom out a little bit. Just that's better. Actually, if I close that, that gives a little bit more room as well. All right. So this. Where's my model? What happened there? Oh, okay. I don't quite know what I managed to do then, but I managed to not open the model that I wanted to use. So anyway, if we go back to data importer, this is the model that we have been using. There are person nodes and movie nodes, and there are acted in and directed relationships between person nodes and movie nodes. What we are going to do is we are going to create a new node within or a new node type within this graph, and a new relationship, and that is going to be users who have rated movies. So our data set contains users and the ratings that those users gave movies. So the model I want to create has a new node label in it, and it's going to be the label of user. So I can create a new label using this add node label, and it gives me this dialog. So I need to specify what the label is. In this case, it's going to be user, and I need to say, okay, well, where am I getting that data from? In this case, in my example, it's coming from this ratings.csv file. The ratings.csv file contains movie IDs, user names, user ratings, and then the timestamp of when they gave that rating. So I created a new user label. I've selected my data source, and then what I want to do is I want to add some properties to this node. And there's a useful feature here called map from table. What that allows me to do is select within that table, within that CSV file, the properties that I want on this node. And actually, there's two. I want the user ID, which is the unique ID of for that user, and I also want their name. So those are the two properties that I want to create on this node, and it creates a mapping between those. So user ID, this is going to be the name user ID and name. This is going to be the name of the property. It has picked a type for me. So based on the data within that CSV file, it's suggested a type, and I can pick integer, string, float, boolean, and it has also set up a mapping between the column names. So this is the column in the CSV file. This is the property, and this is the type. It has also selected one to be the unique ID. So data importer will create the constraints within the graph that says this ID has to be unique for this node label, and it's done that by just selecting the key here. So I now have a new node type within my graph, but it's not connected to anything. It's not connected to anything else in the graph. What I want to connect it to is these movies, so users rated movies. And I can do that if I hover over the edge. It sort of highlights the side of the node, and I can pick it up and I can drag and connect my user node to my movie node. And I'm going to create this relationship. If I select the relationship, it says me, okay, well, you need to have a type. What is the relationship type here? So in this case, I'm going to use rated, user rated movie. And in order to create this relationship, again, I need my data source. Now, in this case, it's that same ratings.csv file. And it's asking me saying to create this node ID mapping. How do I map the relationship between the user ID and the movie ID? And it's asking, okay, well, what column within that CSV file denotes the user ID and the movie ID? And you know, it's essentially, you know, the foreign key, primary key, you know, within that table. So that's going to create my relationship between my user and my movie. And again, I have another opportunity to map properties. So again, relationships within a graph can hold properties, can hold data, and I'm going to do the same thing. I'm going to map from table. And I'm going to say, okay, well, you know, I definitely want the rating. So this is the rating that the user gave that movie. So I definitely want the rating, and actually, I'm going to add the timestamp as well. So, and what I'm going to end up with is a rating that the user gave this movie, and also a timestamp of when they did it. Data importer also. Hopefully, you can see the little green ticks. The little green ticks means that I have done everything data importer expects me to do in order to be able to create that node and that relationship. So once I've done that, I can then run my import again. I run my import. There we go. We see it running this time, and it gives me a summary. So again, it's giving me a complete summary. Interestingly, for person and for movie, while it's processed the data, no new nodes have been created because the person nodes already exist and the movie nodes already exist. But if we scroll down, we will see our user nodes, and it tells me it's created 560 new user nodes and 3,500-ish rated relationships between user nodes and movie nodes. Okay, so that's how we can use data importer to add our own data into Neo4j. Right, let's just pop back to my slides. Share this tab instead. Great. So this is what we have been doing. So now we have a richer data set within our graph. I'm going to look to say, okay, well, how do we start using this data to like answer questions? So pop that back there. So we're gonna create some new queries that and what I want to try and do is sort of take you through the process for how we answer specific questions, how we aggregate data, how we order, and how we limit. And the first question I want to try and ask is, what is the best movie with an actor called Robert? So let's start by doing that, shall we? Okay. All right. So we are going to pop back to, we're going to go back to Aura, share this tab instead. And again, I'm going to use query. So query being, you know, I'm going to write Cypher in order to be able to interact with our database. Let's see if I can I can probably make this a little bit bigger now. Hopefully that's a little bit more visible. All right. So my question is, what is the best movie with an actor named Robert? So the first thing I need to do is I need to find actors or persons that have a where their name. Let's call that Rob, because these are going to be Robs. So match Rob person nodes where Rob.name contains Robert. And then let's just return Rob. So what I should get back is nodes where the name contains Robert. So introduce a new Cypher query. So if you're working with strings, you can use contains. You can also use starts with, so on and so forth. And I get back a graph of nodes that have name containing Robert. Well, in actual fact, I also get back Julia Roberts, as we might expect, but that's not the query I'm looking for. So actually, the first thing I'll do is I'll change that to start with. So match person nodes where the name starts with Robert. So now I get back person nodes starting with Robert. Right. I need to find the actors, and I understand actors by using the acted in relationship to movie nodes, because there's an interesting. So is this actually some of these person nodes returns might be directors, but I can use this to say, okay, well, find me the actors, because I understand they're actors because they have acted in a movie. And now I get back a graph which contains actors called Robert and movies that actors called Robert have acted in. And then we can see there are 4: Robert Downey Jr., Robert De Niro, Robert Blake, and Robert Prosky. Okay, so it's a good start. But if I'm looking for the best movie starring an actor called Robert, I need a way of understanding what is the best. And what I'm going to do is I'm going to use those user ratings we just created to try and work that out. So if we remember, I created a rated relationship between user nodes and movies. So let's bring in the ratings for the movies that Roberts have acted in. So I'm finding my Roberts, the movies that Roberts have been in, and the rated relationships to the users. So now I get back a more sophisticated graph. So this is, if we look right in the middle, we will see the blue nodes being the Roberts, the movies that they have acted in, and then the people that have acted those movies, right? Let's get some data rather than a graph. Okay, so first of all, let's get our Robert name. So I'm going to take rob.name we want the movie title. So I want the title property from the movie node, and then let's have the user's name, and then let's have the rating. So remember, when we created that data model, we created a rating relationship against the rated relationship. So now we get back a big list of all of the users and the ratings that they have given movies starring people called Robert, which is a great start. I now have my data. I've extracted it from my graph, but we can use Cypher to aggregate this data. So, for example, I can use a count function. And this is going to return me the movies, the actor, the movie, and the number of ratings that movie has. Again, if you are familiar with SQL, you may have sort of noticed a key difference here, which is when you're looking to aggregate data using Cypher, you express within the return the data that you're looking to aggregate. You don't have to do a kind of group by or anything like that. You just return the data and say, okay, well, and use an aggregation function to aggregate the data when it is returned. Okay, so that's great. I now get a list of names. But actually, what I want is I want the average rating. So I don't want to count on the average rating. So I can use that's a function called average. So now I get back movies, ratings, and average rating for that movie. I think we're about there. Let's order it by that average rating. And again, if you're familiar with SQL, you'll be familiar with as, that idea of like define a keyword or a variable for this particular field. So I'm going to call this average rating. So order by average rating. Order by, so that's giving me them in the wrong order. So let's do it in descending order. So the best movie with an actor called Robert is Richard III, starring Robert Downey Jr. There were 23 ratings with an average of 4.02173. Great. I've got a data set, and I've managed to answer questions using a pattern that defines the data I'm looking for, a filter. I then return the data that I'm looking for using aggregation functions to aggregate, and then I can then order that by. Lastly, there are 7 here. I only want the top 3, so I can say limit 3. So that's going to give me the top 3 movies starring an actor named Robert. Great. Okay, so let's just pop back to our slides, and again, we've got an opportunity for you to have a go. So again, if you want to use that rated property defined, the movie with the most ratings, and then the top movies based on average rating. So that's your little task while we have a look at see if there are any questions.
Very good. There is one question from Matthäus. Matthäus asks, is it possible to assign more than one label to a node?
Yes, absolutely. Yes. I think it's probably the easiest way to summarize that. Yes. So movies can have more than one label. Is that the last new question we have?
That was the last new question we had.
Okay,
yeah.
all right. Well, what we'll do is we'll spend a couple of minutes just looking at how we do that, shall we? Yeah. But yes, movies can have nodes can have multiple labels. Let's think. I'm going to just very quickly switch back to here and just create a new query. And the way that we do this is, so we have a person label with we have a node with a label person for me. So I can match me. That's going to find that node that has the name person and me. I can then set an additional node label. So Neo4j staff return p. So I've matched the person label. I've then set a new label on that node, and now I have me, who has got 2 labels associated with them. So yes, absolutely you can, you should, and there are good reasons why you would do that. By setting multiple labels against nodes, we can segment our graph in different ways, and actually applying node labels is a really, really effective and efficient way of segmenting the graph so you can write performant queries. So find me all the Neo4j staff would create a sort of subsection of the graph that allows you to query just those nodes very quickly. Okay. Any other questions, Alex, or should we move on?
I don't see any other questions, but anytime.
Okay, let's move on.
Use the Q&A panel if you have more questions, anything is unclear, and we will answer those as you post them.
Okay. Well, let's just spend a moment just looking at how we answer these questions. So the first one being the movie with the most ratings. And again, I'm going to switch back to Aura. So this would be the query. Again, so we use a pattern to find the rated relationships from 2 movies, and then we use that count aggregation function to return those ratings. So Toy Story in this case is the movie that has the most ratings. So the second question I posed was the top 10 movies based on average rating. And again, pretty similar to the examples that I ran through, but again, we use a pattern to define the data that we are looking for, and then we use an order by to order by that average rating, and then that limit of 10. So L'America, not a film I've ever seen, but has the highest average rating. Okay, so let's move on. So this this wonderful slide expresses the fact that graphs help us understand relationships. And one of the nice things about graphs is that you can query the graph through varying numbers of patterns. So there have to be one node through one relationship to another node. It could be I have a start node and I'm looking for an end node, and there could be n number an unlimited number of relationships and nodes between those two things, and graphs can help me find that data. So what we are going to do is we are going to have a look at saying, how can we match up the actor Kevin Bacon to the actor Al Pacino? So let's go back to Aura and we'll look at how we do that. Again, let's just do some tidy up. So the first thing I need to do is I need to go off and find the person node that has the name Kevin Bacon. Let's return KB. And I get back one node. So Kevin Bacon. Let's expand on this query to say, okay, well, let's go off and let's use a second to find Al Pacino. And again, he is there should be a person node with a name property of Al Pacino. And if I return those, I get two nodes back. Now, the thing that I want to do is that I want to find the path that leads me from Kevin Bacon to Al Pacino. And, I could do match KB, any relationship to Al Pacino. And if I return that as R, no changes, right? No changes, no records. And what that tells me is there is no direct relationship between Kevin Bacon and Al Pacino. And I could put it the other way. There is no direct relationship between Al Pacino and Kevin Bacon. That is not a relationship that exists between the graph. We need to explore the graph in order to be able to do that. And one of the functions that we can use is we can use shortest path. What shortest path allows us to do is to return a path of the nodes and relationships between a start node and an end node. So I'm going to say match P, which is the path that I'm looking for. And I need to give it a pattern. So the pattern that I'm going to give it is basically says go from Kevin Bacon. Let's just create a little bit of space so this is slightly easier to read. And I want you to use the acted in relationships, to find any number of steps between Kevin Bacon and Al Pacino. Because what I'm trying to look for is what is a movie that Kevin Bacon has acted in and that Al Pacino have acted in. And I can use shortest path to return that path. It's going to return the shortest path that takes me from Kevin Bacon to Al Pacino. And it looks like this. So what this tells me is the path between Al Pacino and Kevin Bacon is Kevin Bacon acted in the movie Balto. Bridget Fonda acted in the movie Balto. Bridget Fonda acted in City Hall. Al Pacino acted in the movie City Hall. So I can express or discover those relationships with that I didn't know were there. I'm using shortest path. There is also you can also use paths to find fixed numbers of hops. So I'm looking for the thing that's 4 hops away, 5 hops away, or any variable number of hops away. But again, what I'm looking for is the shortest path. And again, what I'm looking at here is person and movies. This could be customers and products, transactions and values. Insert your use case here. In order to kind of make that make sense. Okay. Right. So we have another opportunity for you to have a go to kind of like explore using shortest path. So I've got a query here which fill in the gaps to find the hardest critic, the user who has given the lowest average movie ratings. And then I would like you to find the connection between the hardest critic and Kevin Bacon. Okay. And then we'll take an opportunity to answer any questions.
Super. We have a couple new questions, and funnily enough, Fred and Brian both asked more or less the same question about the difference between using labels and properties, when to do what, basically, and if there is a best case scenario for a label or a property.
So, I mean, the answer to so many of these questions is it depends, right? It always depends. But let's talk about when you would and when you wouldn't, and why you might want to do that, and also some of the options that are available to you. So first of all, what we're thinking about here is querying the graph. That's when having labels and properties allows us to segment our data. So let's think of an example. Let's think about year released, right? Okay, so let's say we have our movie nodes have a property of year released. Yeah. You could create a query that says, find me all of the movies that were released in 1998 by, defining a pattern and then using a where that says, equals 1998, m dot released equals 1998. You could also index that value as well. So you could create an index against that node label and that property, and you could have, a fast way of searching that data, through using an index. And that would be a perfectly legitimate use of a property and an index. Let's say, for example, though, what you wanted to do is, for reasons for your use case, you wanted to find actors who acted in movies released in 1998, and that was something that you wanted to do regularly, or you wanted to do data analysis on that section of movies released in a particular year, right? The benefit of creating a label, so you could create a label against the movie node that says, a label of release 1998. The benefit of creating a label is it allows you to segment the graph in a very, very efficient way. And it allows you to be able to create patterns that use just that segment of the graph. So, it always depends. My rule would be, if you are looking to regularly query and you are looking to find subsections of the graph, so subsections of nodes, then labels are almost always the best way to do it. Yeah. If, however, you're looking to do more complex, like search queries, so let's say you want to find movies that were released between 1998 and 2004, so that's a thing that you want to do quite regularly, an indexed property is probably the best solution for that. So I know it's not a perfect answer because there's no right or wrong in any of these. It depends. Yeah. But if you're looking to segment the graph, do it. Yeah. Do it using labels.
Cool. Yeah. It's a very common question. It comes up a lot of times. It's unfortunately, there is like it depends kind of scenario question where we really need to make sure that whatever you want to do and whatever your most common queries look like is the one that more or less defines if the one or the other is making more sense for your scenario. We have one more question from Mateus.
Okay.
He asks, can relationships rather have properties? For example, in our domain, there is a person who has acted in some movies as primary role actor, but in other, he could be a stunt double or maybe a director. I think you showed this. If you look at the users' ratings, maybe you can show that one more time.
Yes, so absolutely. To answer the question first off, yes, relationships can have properties and more than one property. In fact, any number of properties that you think is appropriate. So yes, you could. So if I just go back here, for example, and share this tab in this graph we were just looking at, if I select the relationship, we can see that the relationship has a property called role, which is Jenna, which is the role that Bridget Fonda played in the movie Balto. And we can also see that Balto, Kevin Bacon played Balto in the movie Balto. Yes, so relationships can have properties in any number of them. And I think your question was about, could I suppose not just the role that they play, sorry, the name of the role they play, but maybe the role type as well. Could be like, yes, absolutely, you could have a role type equals stunt or extra or whatever else was appropriate.
Yep, super. Thank you very much. That's all the question we have for now.
Okay, all right. So let's just have a quick look at the solution to these problems. So what I asked was, let's find the hardest critic. So this was the sort of starting query I gave you. So if we're looking for the hardest critic, what we're looking for is users that rated movies. So I'm going to go off and find the movie. Find movie node.
We only see the slide.
Thank you. So this is the starting query, and we're going to go off and find the movie node, and then we're also going to go off and find the user that rated that movie. If I'm looking for the harshest critic, I want the user's name, and I want the average rating for that relationship. So Tiffany Perez, whoever Tiffany is, her average rating is 0.5 star. I mean, that's pretty mean. All right. So the next question we asked was, let's find the connection between the hardest critic and Kevin Bacon. And the starting query looked like this. So we go off and find Kevin Bacon. We go off and find the user, which will simply match her by the name, which is Tiffany Perez. And so we're going to match between Kevin and the user Tiffany. Now, what I've done here is I've basically said star means any relationship, any number of hops. And in a production environment that has a big graph, this is not a great idea because it really is going to go off and find every relationship between those two nodes. And normally we would restrict this to a number of hops. So you could do like that. So, only five hops. But I'm looking for any path at all. So this is what we get. Okay, so we get Tiffany Perez rated the movie 7, 0.5 star. The user Robert Brooks rated the movie 7, who also rated Balto, and Kevin Bacon acted in that movie Balto. And paths are a really, really useful function of graphs to discover data that you didn't know existed, or connections between data you didn't know existed. Okay, all right. So this is where I am going to draw it to a close, and we will finish with any questions that anybody has to ask. As I kind of said right at the start, this sort of Neo4j fundamentals introduction, is a sort of a bridge version of 4 like fundamentals courses on our Graph Academy platform. They are completely free. They are very hands-on, like we've been been doing today. Huge amounts of opportunity for you to practice, run your own Cypher, and we have lots of learning pathways. So if you're a data scientist and you're looking for a pathway that takes you from Neo4j fundamentals to understanding graph data science, there is a learning path that you can go through, as there are for software developers. So if you're looking to integrate Neo4j graphs into your application, there's a learning path that will take you from the fundamentals to learning how to use Cypher and integrating your application with one of our software drivers, whether that's for C#, Java, JavaScript, Python, Go, TypeScript. I'm sure there are others that I've missed off that list. And then you'll also find free certifications as well. Great. So I think we're just on to any last questions before we're done.
Super. I actually don't see any last questions, but that maybe gives me the opportunity to highlight a couple of things that are coming up from Neo4j. So while you might give you a few more moments to type in any question that you might have, switching over to this one. So if you are interested in watching more video content from Neo4j, we are having regular streams on our YouTube channel. So if you go to youtube.com/@neo4j, you can subscribe and follow our channel there. So for example, next week on the Monday, we do a AuraDB special for featuring how Aura works. I think a little bit what Martin showed in the beginning, but also some new features, some processes, some tips and tricks around working with AuraDB. We will feature there. So if you are looking to use Aura, or if you are a current Aura user and want to know what's possible and maybe some hidden features you have not discovered yet, check out this session on Monday. And on Wednesday, the 16th of April, I'm having a guest from the Graph Geeks community, Amy Hodler, and she and I will talk about advancing GraphRag, so going beyond text to images and audio for a multimodal intelligence. So that's going to be happening on the next Wednesday. And if you are, and maybe this is a little bit too early for the majority of you, but still, nevertheless, Nodes is coming up on the 6th of November, so that's a little while until we have that. But the call for papers is opened, has just opened, and is running until the 15th of June. So if you have a topic, a graphy topic you want to talk about, then you can submit something there. If you are feeling okay, I'm too early in my graph journey to present something, but I really want to know more, then obviously 6th of November is the place to join. It's a full day event following the sun, basically, 24 hours. And you can see lots of interesting presentations from Neo4j experts, but also from community members on all kinds of topics, from graph visualization, knowledge graphs, to AI applications, GraphRag, obviously, and much more. So I'm inviting you all to join and to be part of this event in November. And if you back to the regular things, if you want to know more, if you have now an interest to explore, you have already an Aura free instance, use it, play around with it, get some data going, explore a little bit more, take a Graph Academy course to learn more. And I think with that, at the end, I think there's one more question. Yeah, question comes in from Mike. Out of curiosity, is the certification t-shirt available in Europe or shipped only within the US? The shirt is available for everybody. So no matter where you live, you can complete the Neo4j certification, and you can fill in a form, and you provide us your details of your shirt size and your address, and then you get the t-shirt within a couple of weeks. So anybody can do that. And yeah, I think with that we are at the end of this workshop. Again, thank you very much, Martin, for guiding us through, for interesting slides and very hands-on session today. I hope you enjoyed it, everybody. I hope you had a good time as well. Let us know if this is something you want to see more of in the future. And as I said in the beginning, recordings to the slides, recording to the video and the slides will be shared with you in a follow-up email in the next few days. So look around your email for that, and you can recap on what we did today. And yeah, with that.
Yeah, thank you. It's been great fun. I have really enjoyed it.
Yes, me too. Thank you, everybody. Thank you for joining, and have a good rest of your day.